Yes, students, in this video, we are going to continuing the exercise 13.4. In the last video, we have completed up to 7th problem. No, in this video, I'm going to complete actually 8th and ninth problem. Okay, yes, the 8th question is like this. Let us see the 8th problem. The question is like this. The diameter of the moon is approximately one-fourth of the diameter of the earth. Try to understand the statement properly. Okay, the diameter of the moon in a diameter, approximately one-fourth of the diameter of the earth. ಅರ್ತ್ನ 1/4 ಪಾರ್ಟ್ ಮೂನಿನ ಡಯಾಮೀಟರ್ ಅಂತ ಹೇಳಿ ಕೊಟ್ಟಿದ್ದಾರೆ. ಫೈಂಡ್ ದ ರೇಷಿಯೋ ಆಫ್ ದೇರ್ ಸರ್ಫೇಸ್ ಏರಿಯಾ. ಸೊ ನಥಿಂಗ್ ವ್ಯಾಲ್ಯೂಸ್ ಅಂಡ್ ಆಲ್ ನಥಿಂಗ್ is given. So they have given only one statement that the diameter of the moon is approximately one-fourth of the diameter of the earth. Using this condition, we have to find out the surface area, then we have to find out the ratio of the surface areas. So first, we have to take the diameter of the earth as d1. So here we have to fix the diameter of the earth as d1. If the diameter of the earth is d1, then what is the radius of the earth? Radius of the earth is diameter divided by 2, that is d1 divided by 2. Here we are taking the earth radius as r1. Okay, now according to the statement, the diameter of the moon is approximately one-fourth of the diameter of the earth. So according to that condition, diameter of the moon, we are taking one-fourth of the diameter of the earth. How we got 1/4 into d1? Got the idea now? Because one-fourth of the diameter of the earth, we are taking diameter of the earth as d1. So here that's why the diameter of the moon will be one-fourth of d1. Now next, what we need actually to find the surface area? Radius we need. Okay, and the radius of the moon r2, which is equal to, that is diameter divided by 2. Diameter of the, what actually, diameter of the earth, we got actually diameter of the earth, we got d1 divided by 2. So therefore the radius of the diameter of the moon is 1/4 d1. Okay, so now we are finding the radius of the moon. So radius of the moon is d1 divided by 4 into 2. So that is equal to d1 by 8. Actually diameter divided by 2. Here we got actually d1 divided by 4. No, diameter of the moon is d1 divided by 4. So then radius of the moon is d1 divided by 4, that divided by actually 2. So if we take the reciprocal concept there, d1 divided by 4 into 2, we got actually d1 divided by 4 into 2, that is equal to d1 divided by 8. How we got the radius of the moon? Got the idea, no? d1 divided by 8. Okay, so now we have to find out the surface area of the earth and surface area of the moon. Yes, see here, surface area of the earth S1. So we are taking surface area of the earth as S1, that is 4 pi r1 square. Why r1 square? Because we are taking radius of the earth as r1. Okay, so then 4 pi, I'm keeping 4 pi as it is. Okay, 4 into pi 22 by 7 and substitute ಮಾಡೋದಿಲ್ಲ, ಹಾಗೆ ಇಟ್ಕೊಳ್ತೀನಿ, because we have to find out the ratio ಅಲ್ಲ, ಅಲ್ಲಿ pi ಏನಾಗುತ್ತೆ, ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. So 4 pi r1 is d1 by 2. So radius of the earth is d1 by 2 whole square. Then 4 pi into d1 square. d1 by 2 whole square is d1 square divided by 4. So then 4 and 4 get cancelled. So what is remaining? Pi d1 square remaining. Surface area of the earth is pi d1 square. Now in the same way, we have to find out the surface area of the moon. So what is the surface area of the moon? Surface area of the moon, we have to take as S2. Okay, so then 4 pi r2 square, r2 square. Then 4 pi into radius of the moon is d1 by 8. Okay, d1 by 8 whole square, that is d1 square by 64. Then here 4 ones are 4 16s are. So then pi d1 square divided by 16 is remaining. Pi d1 square divided by 16. See here, surface area of the earth we got, surface area of the earth we got pi d1 square. Then surface area of the moon we got pi d1 square divided by 16. Then required ratio. So that is pi d1 square. Here nothing is there in the denominator, in the sense 1 is there, no? Pi d1 square divided by 1. Okay, that is divided by, so pi d1 square divided by 16. Ratio we are taking. This is, so surface area of the earth. This is surface area of the moon. Then we have to apply the reciprocal addition. Okay, pi d1 square divided by 1 into, so this is pi d1 square by 16 becomes 16 by pi d1 square. Here pi d1 square get cancelled. So 16 divided by 1 is remaining. So the required ratio is 16 is to 1. Here 1 is visible, no? Okay, 1 is visible. 16 divided by 1, final answer is 16 divided by 1. Ratio is 16 is to 1. Yes, got the idea of this problem now? Yes, just look at this problem again. Diameter we have to take d1, then radius is d1 by 2. Diameter of the moon is 1/4 of the diameter of the earth, that is 1 by 4 d1. Then radius of the moon is d1 by 4 divided by 2. So in the reciprocal concept, that is d1 by 4 into 2, that is d1 by 8. Then surface area of the earth we have to find out. Then surface area of the moon we have to find out. Then we have to find out the ratio of earth and moon. So 16 by 1, that is 16 is to 1 is the answer for this question. This is about the 8th problem. Now let us move on to 9th question. Okay, see here, 9th problem is like this. A right circular cylinder, okay, right circular cylinder just enclosed a sphere of radius r. Okay, a right circular cylinder, are you observing the cylinder here? Just enclosed a sphere, okay, of radius r. Radius is mentioned as r, not any value. Okay, find. So using this concept, what we have to find here? Surface area of the sphere we have to find. Next question, curved surface area of the cylinder we have to find. Then ratio of the areas obtained in question number 1 and question number 2. So here surface area of the sphere something will get, no? Then curved surface area of the cylinder. So then we have to find out the ratio of these two. What is this? No values and all. What is the concept given actually? Sphere ಏನಾಗಿದೆ ಸಿಲಿಂಡರ್ನ ಒಳಗಡೆ ಕರೆಕ್ಟ್ ಆಗಿ ಕುತ್ಕೊಂಡಿದೆ. Okay, so what we are observing is here height of the cylinder is nothing but diameter of the sphere. That we have to observe properly. Illenagide actually height of the cylinder correct agi diameter of the sphere ge match agta ide. Okay, so next, first question. What is the surface area of the sphere? Yes, of course. Cylinder ಒಳಗಡೆ sphere ಕುತ್ಕೊಂಡ್ರು ಕೂಡ surface area ಅದರ surface area ನೇ ಆಗಿರುತ್ತಲ್ವಾ? ಏನು surface area of the sphere actually? Surface area of the sphere is 4 pi r square. First question answer is very simple. Just surface area of the sphere is 4 pi r square. Next, curved surface area of the cylinder we have to find out. Curved surface area of the cylinder. So just recall the formula to find out the curved surface area of the cylinder, that is 2 pi RH. 2 pi RH. That is 2 pi R. We have to fix 2 pi R as it is. H. I told no, H is equal to diameter of the sphere. Can we read the diameter as 2 times of R? 2R, no? So here we are substituting H as 2R. Okay, so then 2 pi r into 2r, which is equal to 4 pi r square. So we got the CSA of cylinder also 4 pi r square. Why we got the CSA of cylinder? So in CSA of cylinder concept, you cannot take the formula 4 pi r square. In this situation, okay, a right circular cylinder just enclosed a sphere. In this situation, actually CSA of cylinder becomes 4 pi r square, because height is equal to diameter. Diameter we can take to r. So that's why 4 pi r square. Then what we have to find in the third question? Ratio of the areas obtained in question number 1 and question number 2. So ratio of 1 and 2 is, so 1 is 4 pi r square. Then second one answer is 4 pi r square. 4 pi r square is to 4 pi r square, that is 4 pi r square divided by 4 pi r square. So 4 pi r square once, 4 pi r square once. So 1 is to 1. So the answer is 1 is to 1. Got the idea of this problem, students? So this is about the exercise 13.4 solutions. Okay. So next in this video only, just I want to continue exercise 13.5. What is this exercise 13.5? Exercise 13.5 is related to volume of cube and cuboid. Already we discussed the problem formula in the first video only, no? While explaining the lateral surface area and total surface area of the cube and cuboid, I have completed the concept of volume of cube and cuboid. So taking that volume formula, today I am going to explain one or two example problem and I want to give exercise 13.5 as today's homework. Can we start the volume concept now? Let us recall the volume formula once. Okay. So now just I want to go to stop sharing. Then I want to use the board for this concept. Okay. 1 second. Yes, students. So here I'm going to explain volume of a cuboid and volume of a cube. So in the first video only we have completed. Still just I want to recall one's formula. Volume of a cuboid. So we all know volume in the sense it is depending upon the base area and height. So here also volume of cuboid is base area into height and volume of a cube also base area into height. So what is that base area? So let us derive the formula once again. Volume of a cuboid, which is equal to base area into height. Okay, base area into height. So you all know cuboid shape, right? What is the base area? Base is in the shape of rectangle. No, you all know rectangle area is L into B. Okay, into height. Okay, height is represented by the letter H. So we are taking this one as H. L into B into H. Okay, so what is the next volume of the cuboid final formula? That is LBH cubic units. Okay, cubic unit. So, what is the volume of a cuboid? Volume of a cuboid which is equal to LBH cubic unit. Got the idea of this one now? Now, same to same. Volume of a cube. So, okay, now volume of a cube is equal to, again, base area, okay, base area into height. So now cube, just imagine cube. So each face is a square face. All the faces are equal and each edge we are taking as small a. Okay. Now base area, square face. What is the area of square actually? A square. That is a square. Into height. Usually height will take it as small h, right? But here each edge, height and all equal. So that's why each edge of a cube we are taking small a only. So in place of height also, I'm going to substitute small a only. So a square into a, that is a cube. Okay, volume of a cube which is equal to a cube cubic units. Got the idea of this one now? So volume of a cuboid and volume of a cube. Now, using this volume concept, so we have to solve few problems. Can we look at one or two example problems so that you are able to solve exercise 13.5. Okay, now I am going to solve exercise, okay, example problems. Yes, students. So now let us discuss one example problem, that is example 11 in your textbook. You just go through that. You have the solution in your textbook also. You just go through that. Just I want to explain that problem. Okay. Example 11. A wall of length 10 meter was to be built across an open ground. Wall. Okay. A wall of length 10 meter was to be built across an open ground. The height of the wall is 4 meter. The height of the wall is 4 meter. And thickness of the wall is 24 centimeter. Thickness in the sense the breadth. We can take that as breadth. Okay. Thickness of the wall is 24 centimeter. Okay. If this wall is to be built up with bricks, this wall is to be built up with bricks. Okay. Whose dimensions? Bricks also example for cuboid only. Wall is also example for cuboid. Wall, we can observe the shape of cuboid in the wall, no? And bricks. So ಅದಕ್ಕೆ ಯೂಸ್ ಮಾಡೋ ಕಲ್ಲುಗಳು ಅದು ಕೂಡ cuboid shape. You can imagine that problem, no? Okay, so the bricks whose dimensions are 24 centimeter into 12 centimeter into 8 centimeter. How many bricks would be required? ಹಾಗಾದ್ರೆ ಆ ವಾಲ್ ರೆಡಿ ಆಗಬೇಕು ಅಂತಂದ್ರೆ ಎಷ್ಟು ಬ್ರಿಕ್ಸ್ ಗಳನ್ನ ನಾವು ಕೊಡಬೇಕು ಅದಕ್ಕೆ. ಸೊ ವಾಟ್ ಹೌ ವಿ ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಔಟ್ ಆಕ್ಚುಲಿ. ಸೊ ಯು ಕ್ಯಾನ್ ಹ್ಯಾವ್ ದ ಐಡಿಯಾ ನೋ. ಸೊ ವಾಲ್ಯೂಮ್ ಆಫ್ ದ ವಾಲ್ ಡಿವೈಡೆಡ್ ಬೈ ವಾಲ್ಯೂಮ್ ಆಫ್ ಒನ್ ಬ್ರಿಕ್ ವಿ ಹ್ಯಾವ್ ಟು ಫೈಂಡ್. ಸೊ ಪೂರ್ತಿ ವಾಲ್ಯೂಮ್ ಆಫ್ ದ ವಾಲ್ ಅಲ್ಲಿ ವಾಲ್ಯೂಮ್ ಆಫ್ ಒನ್ ಬ್ರಿಕ್ ನ ನೀವು ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ ಯು ವಿಲ್ ಗೆಟ್ ದ ನಂಬರ್ ಆಫ್ ಬ್ರಿಕ್ಸ್ ರಿಕ್ವೈರ್ಡ್ to construct the wall. Okay, so now what is given? First we have to list out. So here we have the solution. In your textbook also you have the solution. So first I took the information of wall here. So is it visible now, students? So if it is not clear, then just use your textbook. Okay, so wall, here wall length is 10 meter, but thickness is in centimeter. So I took the observation, actually given data in the centimeter only concept. Okay, because in the brick every unit in centimeter only. So here 10 meter in the 6000 centimeter, then thickness that is 24 centimeter, then height is 4 meter, that is 400 centimeter. So centimeter, centimeter, centimeter. So uniformity. Okay, this is about the wall information. Now what is the volume of the wall? Length is given, breadth is given, height is given. Wall, we can imagine that wall is an example for cuboid shape. So volume of the wall which is equal to length into breadth into height. That formula we have to use. Volume of the wall which is equal to L into B into H, that is 1000 into 24 into 400. I'm not going to multiply here. Why I'm not going to multiply here? Because so we have to find out the volume of the wall divided by volume of the brick. No? In that we can easily do the cancellation. Okay, we can divide. So that's why. So no need to multiply this in this step only. You just keep this answer as it is only. 1000 into 24 into 400. Okay. So that much centimeter cube volume of the wall. Now let us move on to brick topic. Now let us collect the data of brick. What is given actually? Length of brick is 24 centimeter, breadth of the brick is 12 centimeter, and height of the brick is 8 centimeter. Therefore, volume of brick is again L into B into H concept, 24 into 12 into 8. Got the idea of this one now? Volume of the wall and volume of the brick. Now, number of bricks required to construct the wall. How do you find out that one? So, volume of the wall divided by volume of one brick. Okay, so that is what number of bricks required is equal to volume of the wall divided by volume of each brick. Okay, volume of the wall divided by volume of each brick. So now volume of the wall 1000 into 24 into 400 divided by volume of each brick is 24 into 12 into 8. Here you can do the cancellation and all. That is easy for you. Okay, 24, 24 you can cancel. So remaining you can simplify. After the simplification, okay, final answer is 4166.6. 4166.6. Exactly, can we take 4166.6 only we need? No. So we have to take actually 4167 bricks. Okay. Approximately next. So 4167 bricks we need to construct the wall. So the wall requires 4167 bricks. Got the idea of this problem? A very simple question. Okay. So here volume of the wall we have to find and volume of the brick. So first you have to imagine. So which shape actually wall and brick. So both are example for the cuboid shape. So volume of the wall, volume of the brick, then volume of the wall divided by volume of brick, which is equal to actually final answer is 4167 bricks we need. Got the idea of this one problem now? Yes. Now let us move on to example 12. There is one small problem, example 12. You just go through your textbook. A child playing with building blocks. Are you observing the diagram in the textbook actually? A child playing with the building blocks. ನೀವು ಎಲ್ಲ ಆಟ ಆಡಿದ್ದೀರಾ ಗೊತ್ತಿದೆ building blocks ಒಂದು ಜೋಡಿಸ್ತಾ ಹೋಗಿದ್ದೀವಿ. So ಅಲ್ಲೊಂದು building block ready ಆಗಿದೆ. Okay. Which are of the shape of cubes. Which are of the shape of cubes. has built a structure as shown in figure. ಅಲ್ಲಿ ಒಂದು structure form ಆಗಿದೆ. ಆ structure ನಿಮ್ಮ textbook ಅಲ್ಲಿ ಇದೆ. Okay. If the edge of each cube is 3 centimeter, edge of each cube is given that 3 centimeter. Find the volume of the structure built by the child. ಹಾಗಾದ್ರೆ we have to find out the volume of the structure. Are you observing the structure in your textbook? So you can see this structure. Okay, you just go through your textbook. Here you can observe this structure. So this structure volume we have to find out. How can we find out the volume of this structure actually? So we have to find out the volume of one cube. No, this structure is made up of cubes. How many cubes are there? Just you have to count 1, 2, 3. So can you count that one? So how many cubes are there in the structure actually? So here we are observing the number of cubes in the structure is that is 15. Okay. So number of cubes in the structure is 15. Then volume of each cube you have to find out. Cube volume you can easily find out. What is the formula to find out the volume of cube actually? A cube. So that is volume of each cube is a cube. So each edge is given that 3, 3, 3, 3 cube. 3 3s are 9, 9 3s are 27. So volume of each cube is 27. Then here we have in this structure actually we have total 15 cubes. So then one cube volume is 27 in the sense what is the volume of 15 cubes actually? So that is 15 into 27. So the answer is 405 centimeter cube. So that is the solution is in your textbook only. Can you follow this one? Okay. Yes. So I think you have the idea of this volume concept, okay? Volume of cube and volume of cuboid. Now here we have exercise 13.5. So now you can solve this question. Total 9 problems are there in the exercise 13.5. You just go through that problem, read the problem carefully and try to work out the problems. Okay? So we'll discuss the solution of these problems in the next video. If you are having any confusion, you can ask. Many students are there sending their doubts, okay, but only few, not all, okay. So we are expecting from everybody response, whether it is understanding or not. So if you are having any confusion, you can discuss with us, okay. So now I want to end this video with this homework, okay. That is exercise 13.5 is today's homework. Tomorrow in the next video, I'll bring the solutions of that exercise 13.5. Okay, students, see you in the next video.